before you can do page 8, you need to understand what radical expressions are. This is a radical expression. The number 2 is known as the index of the radical. The number 4 is called the radicand, and the sign, this sign here that looks like a division sign but it's not, is called the radical. The index tells you that you need to find the number that when you multiply it times itself gives you 4. So since we've got radical 4 with an index of 2, we need to find a number that when we multiply it times itself twice gives us 4. So one thing we can do is start with the number 1 and multiply 1 times itself to see if we get 4. 1 times 1 equals 1. 2 times 2 equals 4. There we go. We just found it. The answer to this problem is 2, because the number that when you multiply it times itself gives you 4 is 2. Here we have a number with a radical with a radicand of 64 and an index of 3. It's different than the one we just did. The one we just did had an index of 2. This one has an index of 3. This 3 tells me that I need to find the number that when I multiply it times itself 3 times will give me 64. Well, again, I'm going to start with the number 1. Well, 1 times 1 times 1 equals 1. 2 times 2 times 2 equals 8. 3 times 3 equals 9 times 3 equals 27. 4 times 4 equals 16, and 16 times 4 equals 64. So my answer to this problem, to this radical expression, is 4, because 4 times itself 3 times gives me the radicand, which is 64. Radical expressions are basically the opposite of exponential equations. With exponents, we start off with the base of 3, and we end up with what would here be the radical. Let me change this to 27. So we start off with the base of 3 and exponent 3, and we multiply 3 times 3 times 3 equals 27. So we get our radicand. And the radical is backwards. We start off with our answer, which is 27. Whoops. Which is 27. And we ask, well, what's the base going to be? And our answer that we get is 3. You notice that the index and the exponent are the same number. So radical expressions and exponential expressions are related, just like multiplication and division is related, and just like addition and subtraction is related. Let's go on to apply what we've just learned on page 8. Here we have a radical. We have a radical with a radicand, 100, and our radical, and we don't have an index. Actually, we do have an index. When there's no index, the index is understood to be 2. Remember that. When you don't have an index, the index is understood to be 2. So in all of these, the index is understood to be 2. So what this means is this 2 tells me that I've got to find the number that when I multiply it times itself twice gives me 100. So what I did in the previous page was that I started with 1. Well, I already know that 1 times 1 is not 100. I even know that 5 times 5 is not 100 because 5 times 5 is 25. So what about 8 times 8? Well, 8 times 8 is 64. Well, what about 9 times 9? No, 9 times 9 is not the answer because 9 times 9 is 81. But I'm getting closer to 100, so maybe it's 10 times 10. Let's check. 10 times 10 equals 100. So that means that our answer to this radical expression is 10 because 10 times 10 equals 100, which is what our radicand is. Let's do another one. Here they want us to find what number when I multiply it times itself gives me 1, and what number when I multiply it times itself gives me 16. Well, we know that the number that when you multiply it times itself gives you 1 is 1. But we don't know what the number that you multiply times itself gives you 16. So we start counting by 2's maybe. 2 times 2 is 4. That's not it. 3 times 3 is 9. That's not it. 4 times 4 is, voila, 16. So that's our answer, 4, because 4 times 4 equals 16. Now you figure out 121. Let this be a hint. Well, you know 10 times 10 is 100, so you know that whatever the answer is, it has to be more than 10. Okay? Because 10 times 10 is 100, and they want you to find 121. So your answer has to be more than 10. So start counting by 11. Check if 11 times 11 equals 121, or 12 times 12. One of these two has to be the answer. So you figure it out and try to decide which one the answer is, 11 or 12. Here we have an index of 3. So that means that we have to find the number that when we multiply it times itself 3 times gives us 1,000. So it's probably going to be a number closer to 10 than anything else. In fact, I'm going to start off by counting by 10. So I'm going to multiply 10 times 10 times 10 times itself 3 times to see if that's my answer. Well, 10 times 10 is what? 10 times 10 equals 100. And 100 times 10 equals 1,000. So my answer is 1,000. And that means that the answer to this radical is, is 10. The answer to this radical is 10. Okay, now you tell me what number, when you multiply it times itself 3 times, gives us 27. Start by counting with 1s, then go up to 2s, then go up to 3s. Multiply your 2s times themselves 3 times. See if they give you the number. If 2 isn't it, try 3. And keep going until you find 27. Okay? Here they're asking me to find the number that when you multiply times itself 2 times gives you 4, and the number that when you multiply it times itself 2 times gives you 9. So I already know, my brain already tells me that the answer here is 2 because 2 times 2 equals 4. And my brain tells me that the answer here is 9 because 3 times 3 is 9. So my answer is 2 over 3. Make sure you do 5 and 3 over here, okay? Don't forget to do those.